Athlete's custom paddles. Made from 250-year-old cypress. Harvested from 100 acres. Half-automated, mostly handmade. Each paddle can cost over $100. They even use aerospace-grade fibers inside, and precision most people have never seen. So with such a paddle, can an athlete really win championships and reach the Olympics? Making paddles always starts with wood. Here they chose local cypress trees aged 250 years. Fine texture, hard to crack. Before cutting, nails are fixed on both sides of the saw. Workers guide the blade by hand to cut. The wood is large in size. It takes at least 10 minutes to split one piece. And this is only the rough material. Here, much of the bark and outer layer is useless. So the log is cut in half again. Starting the second cut. Whether the paddle is good depends on precision. So every cut must be marked with a pen first. Then the log is divided into 8 parts, laid out like flower petals. This leads to the most wasteful step. Put simply, from one triangle block, maybe 2 usable sheets, half of it becomes scrap. Then workers plane the boards again, reducing thickness down to 1 millimeter. Then carbon fiber and 4 types of wood are glued together. Note that high-end paddles don't use just one kind of wood. To reduce vibration, workers sometimes add cork inside, so the paddle lasts longer. Then the glued sheets go into a roller press. Pressure makes them more solid. Interestingly, they press at least 4 times, not all at once. Adjusting carbon fiber and wood step by step. This lowers output, but profit stays high. The cheapest is thousands, the priciest tens of thousands. Next is fine cutting. Boards are laid on the table. CNC machines trim the edges. With 4 preset molds on the table, the blades follow the program, making exact paddle shapes. As the machine moves, it reaches the last mold. Not very fast, but not very slow either. 2 minutes makes 4 in a normal factory. This would be too inefficient. Then wood chips are blown off, and another worker sands the paddles. This is a key step before the paddle is finished. So the worker is very careful. Every length and width is measured, one by one, as the blade takes shape. Next is the handle, made from a special hardwood, different from cypress, harder to the touch, denser in structure. Even sweaty palms won't ruin the grip over time. Then the clamp is tightened, and the machine runs, cutting with a rotating blade. Online reviews are mixed. Some say price doesn't equal quality. Some say the best is what suits you, but is that really true? Here's before cutting on the left, and after on the right. Smooth with no burrs. Looking around, top players all use custom paddles, adding carbon fiber layers for effects that cheap paddles can never achieve. In China, Jiang Jike, Ma Long and Fan Zhendong all use carbon fiber blades. The trend is moving toward fiber and carbon. Carbon blades are lighter than 5-ply wood. Workers attach handles on both sides, then press for long reinforcement. This takes a lot of time. When removed from the press, the body is formed, taken to a grinder. Edges are polished to prevent splinters. Though just sports gear, handle precision is critical. Every diameter checked with calipers. After this first step comes painting, including large brand marks. Each racket has its logo, here shown with placeholder text. How to ensure quality. Each factory has its tests. Like here, worker uses a plastic sheet sliding into layers. If tight, it passes. Flatness is also tested. Instrument stands on the blade. Rotate and check readings. The racket is done. Now 1 more minute to see how balls are made. Balls are injection molded from PPG ethylene. Heat melts the pellets into any shape. Half shells are formed, then delivered, fused in a black chamber. Heat leaves seams. Invisible joints remain. So special blocks are used. Friction and impact Polish the surface. Time depends on material. Match balls weigh only 2.7 grams. Machines run slowly to avoid damage. In pro matches, how to ensure quality. Optical inspection. Balls roll on a conveyor into a chamber. Probes take 1 shot per second. Continuously, any flaw is detected. This method is standard today. So which is better, high-tech carbon racket or traditional 5 to 7 ply wood? Which do you prefer?